Carbon capture and storage, CCS, is a process designed to mitigate the release of carbon dioxide, CO2, into the atmosphere from industrial processes or power generation. Here's how it generally works. Capture. The first step involves capturing CO2 emissions produced from industrial processes such as power plants, cement production, or other large-scale industrial facilities. There are three main methods of capturing CO2. Pre-combustion capture. CO2 is captured before fuel is burned by converting it into a gas called syngas, primarily composed of hydrogen and carbon monoxide. Post-combustion capture. CO2 is captured from the exhaust gases after fuel combustion using various absorption or adsorption techniques. Oxy-fuel combustion. Fuel is burned in oxygen instead of air, resulting in a flue gas stream primarily composed of CO2 and water vapor, making it easier to capture CO2. Transport. Once captured, the CO2 is transported from the capture site to a suitable storage site. Transportation methods can include pipelines, ships, or trucks, depending on the distance and volume of CO2 to be transported. Storage. The captured CO2 is injected deep underground into geological formations for long-term storage. Suitable storage sites include depleted oil and gas reservoirs, saline aquifers, porous rock formations saturated with salty water, and deep coal seams. The CO2 is injected under pressure into these formations, where it is trapped by impermeable rock layers and geological structures. Over time, the CO2 becomes trapped as a supercritical fluid or dissolves in the underground water. Monitoring and verification. Once the CO2 is injected into the storage site, continuous monitoring and verification are essential to ensure the integrity and safety of the storage operation. This includes monitoring the injection process, measuring CO2 storage capacity, and assessing any potential leakage risks. CCS has the potential to significantly reduce CO2 emissions from large industrial sources, helping to mitigate climate change. However, challenges remain, including the cost of capture and storage, regulatory frameworks, public acceptance, and the need for infrastructure development. Continued research and development are essential to improve the efficiency and cost-effectiveness of CCS technologies and accelerate their deployment on a larger scale.